here's another type of simplifying complex numbers problem. In the end, we want to write this complex number as a real part plus an imaginary part or a complex part. That's not possible when there's a complex number in the denominator. And so whether you want to call it rationalizing the denominator because that I has a square root in it, or whether you want to call it rewriting this thing as an a plus bi, we've got to get rid of that I from the denominator. It just can't stay there. It can't live down there. And that's where the tricky part comes in. Because if I just multiply this thing by I over I, that'll be great for this because I'll get I times I, and then I'll get I squared, which is -1. The problem is that I that I multiplied by the whole denominator, it will distribute through and it would hit that 2. And that doesn't work because then I'm still stuck with an I in the denominator of the problem. Remember, I like to talk about analyzing math as like you're analyzing chess positions. And you're looking a few steps ahead, trying to figure out what to do. Well, we just looked like 3 steps ahead of trying I divided by I and multiplying by that. It did not work. Okay. What I really want to do is square that term. I sort of don't care what I do to this term. It's real. As long as what I do to it keeps it real, that's all I care about. Is there a way from our memorized patterns to square this term and square this term? And the answer is sort of. We'll have to change this sign while we're at it. Remember our difference of squares pattern. Our difference of squares pattern was a squared minus b squared, and it equaled a plus b times a minus b. Well, that looks an awful lot like an a plus b. This is what I want, or will do the job. And so what I need to do is I need to figure out what I need to multiply by to get this a minus b involved. Well, if a plus b is 2 plus I, then a minus b is going to be 2 minus I, right? This pattern of just changing the sign between the real and complex parts of a complex number, it occurs so often we give it a number or we give it a name. We say that 2 minus I is the complex conjugate of 2 plus I. And so what do I want to do? I want to multiply above and below by 2 minus I, the complex conjugate of 2 plus I. But I can't just do that on the denominator or I'll change the value of my problem. And so I multiply above and below by that. All right, well, what does that leave me with? That leaves me with 2 squared minus I squared for the denominator, which is super nice because that minus I squared becomes minus a -1. So I get 4 minus a -1. Let's write this out. I'm thinking too far ahead, not writing enough down. All right, so when I multiply this out, I'm going to get I times 2 minus I divided by. Well, if I multiply those guys out, I get a squared minus b squared. So it's going to be 2 squared minus I squared. Okay, so now I have 2I minus I squared over 4 minus -1. Well, that's the same thing as saying minus a -1, that's a +1, and then plus 2I, and divided by 5, divided by 5. And the reason we need to break this into 2 fractions is because this is my a plus my bi. And we typically want to report these complex numbers as a plus bi. A real part and a complex part or an imaginary part. I hope this helps with our understanding.